Hello, everyone, and welcome to the York Observatory's Teletube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Alumni Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle at York Observatory and Facebook at Alan I. Carswell Ops. Good evening, everyone. I'm Maheen, and I'll be one of your hosts this evening along with Arfa, Shannon, and Matt. We're here from the Alan I. Carswell Observatory at York University. Tonight, we've got a great presentation for you all about the biggest planet in our solar system, Jupiter. We also have some live observing tonight, so stay tuned. Before we get started with our main show, we want to give you a little update on what you can see this coming week. Tonight, right after sunset, the very bright planet Venus will gleam above the double star Regulus in the constellation Leo near the western horizon. Have a look out for an object that looks like a very bright star and will most likely be Venus. Mars will also be visible at the lower right of the duo. To be able to view the duo and Mars, back your telescope and binoculars is a good option. Our topic of today, Jupiter, will also be visible later at night until sunrise in case you're planning to stay up. Tonight, the moon is in a waxing gibbous phase, meaning that it is 50% illuminated and will last about 7 days until it becomes a full moon. Before we get started with the presentation, I will hand the screen share over to Connor and Laure to show us some live images from the 1-meter telescope. As you can see, we're looking at Venus right now, and I do have some fun facts prepared for you all. So, a fun fact that I'd like to share while we're having a look at this planet. A day on Venus is longer than a year. Thus, it takes longer to rotate once on its axis than to complete one orbit of the sun. And that's very that's very amazing to me because it would be very weird to be living on a planet where a day is longer than a year. Another fun fact that I have is that Venus is hotter than Mercury despite being further away from the sun because of high concentrations of carbon dioxide in the atmosphere, resulting in extreme greenhouse effect and heat trapping. So it's just like how global warming occurs on Earth, and just the similar phenomena are on Venus, resulting in it to have a warmer environment, even though it is farther away from the sun than Mercury. So does anyone else have any fun Venus facts to share with us?
Sure. So I have one. So unlike the other planets in our solar system, Venus spins clockwise on its axis, which is kind of very weird because if looking at perspective from Earth, imagine having, I don't know, sunsets in the other side of the planet. And I don't know, I just find it very weird. But I have also one more fact, and it's kind of amazing one, which is Venus has 90 times the atmospheric pressure of Earth. So yeah, I don't know. It's so weird. I guess Shannon has one more fact.
Yes, thank you, Arfa. I wanted to add that even though Venus is the second closest to the Sun, Mercury being the closest, it's actually the hottest planet in our solar system. So you're probably wondering, how is it the hottest planet in the solar system if it's not the closest? Well, Venus has a very prominent atmosphere, and besides Earth, it's the only planet in our solar system that actually has a prominent atmosphere. And what this atmosphere does, it's kind of like a greenhouse effect, and it keeps all the heat in. And I just think that's really cool because Venus is named after the goddess of beauty and love. So it's kind of cool that it's the hottest planet in our solar system.
Thank you, Shannon, for sharing such a nice fact with us. It's amazing how we can just compare different planets with each other, like comparing Earth with Venus, and understand it better, because obviously we're living on Earth, so we can relate to it better.
Yeah, like it's so weird how Venus is it's actually similar to planet Earth if we date back to like quite 1,000 or let's say million of years, but it is actually known as the evil twin sister of Earth. So I find it very funny.
Let's see what other objects we'll be able to see tonight. Looks like we're trying to find some other objects that are visible tonight. There are some good objects out there. So Regulus is out there actually. And we'll see what others are possible to see.
Actually,
Just
today we are lucky enough to have a really clear sky. In the past few Teletubes and OP, we have been trying to have one, but today is our lucky day, guys.
exactly. We have not had clear skies in a while, and it's a great thing that we were able to see Venus that clearly tonight.
Yeah,
I guess
100%. Especially since on Monday we did have a clear sky per se. We didn't really have any clouds, but because of the wildfire and everything, we had a lot of smoke in the North Europe area where the observatory is. So sadly, we weren't able to
Definitely.
do live observing.
yeah, even the color of sun was different, and even for moon, for a second, I was like, okay, and like it. I found it very weird, guys. It was so weird.
It was almost like the blood moon in the middle of the year somehow.
Yeah. Are we?
So,
We are trying to look at Regulus right now, right?
yes, I believe so. Looks like there's some disturbance. I wish Mars was visible tonight as well, but it's a bit lower in the sky, so we won't be able to see that.
Yeah, like I looking through planets through telescope is a whole other experience. I mean, until
Okay,
unless we're
so
sorry,
go
yeah.
ahead. Go ahead, Arfa.
Until unless we are not able to, I guess we do see Venus. We are back to Venus now, but okay. I mean, someone else has some other fun facts for Venus.
I think we did a lot of fun facts on Venus. Although we cannot view Regulus, why don't you go ahead and share with us some Regulus facts, Arfa?
Sure, I got a lot of them. So Regulus actually is Alpha Leonis, meaning prince or little king in Latin. And it is the brightest star in the constellation Leo, and it is the 21st brightest star in the entire sky. Wow. It is actually has a four-star system made up of two binary pairs, like so it's like if we have a closer or have a more better view, we can actually see four stars orbiting around each other, so that's pretty amazing. And one more fact I got, it's like it is around 1 billion years old, so much older than our sun, I guess, but okay. And Regulus is 79 light years, approximately 24 parsecs distance. And one more, last but not least, it has around 3.8 solar masses. So it's bigger than our sun, though its primary companion, Regulus B, is smaller and it only has 0.8 solar masses.
Nice. Thank you for sharing that with us and enlightening with us all about Regulus. I guess we're having a bit of bad luck with other things, but we are looking at Vega right now.
It is also very bright outside because it is summer. So
Yeah, and I feel like it's
There it
very.
is. There it is.
Yay, we found Vega!
Yeah.
So Vega is the brightest star in the northern constellation of Lyra. So it is visible a lot actually because of how bright it is.
And did you know that it's actually termed to be arguably the next most important star in the sky after the sun?
Oh,
Wow.
really?
Yeah,
Yeah.
it's because it has functioned as the baseline for calibrating the brightness scale. And it was one of the stars used to define the 0 point for the photometric system. So it's quite important, even though it's a normal star for us. We could say it's pretty important in the world of astronomy. So
Yeah. And it's the brightest star, although it's like 25 light years away from the sun, and its age is 1/10 of our star's sun. So, I mean, clapping for the star Vega to be too bright.
and then
Another.
even though you say it's young, it's about 450 million years old. So
Oh my
it's
God.
yeah,
I mean, compared to our sun.
of course, of course.
I mean, it does have a very high surface temperature, so it's like 9,602 Kelvin. Maybe, that contributes to why how bright it is.
And
Yeah.
yeah.
Yeah, Matt, do you have any other fun facts to share with us?
Um, yes, so it's actually I wouldn't know how to say this,
Mm-hmm.
but so the this star was really important in the Chinese culture as well as in the Polynesian and in the Arabic culture, and its name actually comes from the word Waki or Vaki
Mm-hmm.
from the Arabic language, which means falling or swooping. That's what I researched on Vega, and it's really interesting. I don't know why they called it like as a falling star, but that's where its name comes from apparently. And yeah, that's also one of the things that baffled me, because if something is important in astronomy for your or a culture, everything has a reason to be. And I don't know, maybe they thought it was falling because it was so bright.
That's kind of sad to like derive its name from like the falling star.
I don't know.
Yeah, that's kind of sad, I would say.
Maybe they thought it was brighter than anything else because it was coming
Mhm.
closer towards them. I don't know.
I
So
mean, in old times,
apparently,
yeah, in old times they would name for whatever makes sense to them.
Yeah,
We can't blame them.
yeah.
so Arfa apparently wants to share with us the star type,
For
Vega.
sure.
Yeah, actually, one scientific fact now, it
Mhm.
is a blue-white main sequence. So if talking about in technical terms, it's A0V8 type of star.
I see. That's interesting. There's also some other facts. Okay, so Vega has a circumstellar dust cloud. So it's like something you would expect to see in a forming planetary system. That's pretty interesting. So I would expect that maybe there is something developing around Vega, but I mean I don't know. But
It's
that's quite
still too
interesting to
young
know.
though. So we would have to wait a
Mm-hmm.
little bit to see something forming there, right? I don't know.
Yeah.
The solar system is like 6.4 years billion, 6.4 billion years old, and this one is like
I think it's
400.
4.6 billion years old.
I'm sorry?
4.6 billion years old?
I think it's 6.4. I'm not sure. But the
Mm-hmm.
thing is that Vega is only 450 million, as I said before. Yeah, it's
Oh, so it's
4.6
a young
billion.
star.
Yeah.
Mm-hmm.
So yeah, it's pretty young compared to the solar system, but still, yeah, we could see something forming there. And did you know there's also another interesting fact about Vega? It's not only one of the most important stars in the sky, but it was also one of the first one. It was actually the first star to be photographed after the sun.
Oh,
Um,
really?
yeah,
I didn't
the
know that.
yeah astronomers capture an image of it on 1850. So yeah, it's a while ago.
Is
Yeah,
that
that's
because of
pretty
how
early.
bright it is?
Yeah.
I see.
I got a few more facts for star Vega. So there's that it appears that the star has a low abundance of elements with a higher atomic number than that of helium. And our sun rotates on its axis in about 28 days. Vega, on the other hand, rotates much faster, which is like 12 and a half hours. So 28 days compared to 12 and a half hours with a speed of 236 kilometers per second at the equator. That's fast, guys. So, and also because it's a new star, we get to see some circumstellar disk of dust around it, possibly because there might be some collisions going on. I
I
guess we should
mentioned this
move on to
before,
our.
but go ahead. Go ahead.
Yeah. I mean, let's try for another star, another galaxy or something, I guess.
Okay, so we're gonna
For sure.
be moving on, and we're gonna try some other things that we can see. Maybe fingers crossed, we're trying to point to Arcturus. So let's see how that goes. Um, yeah, let's see.
To look and find some stars and everything, there's so many factors that come in, like the light pollution, how clear the sky is, the clouds, how bright the sky is right now because of the sun. I mean,
Exactly.
Are we able to
yeah,
see something there?
Yeah, there's something on the top left corner.
Yeah.
yeah.
All right, there it is.
Today's
Nice.
our lucky day, I guess.
So, because you were talking about Vega, it's actually like the second brightest star in the northern celestial hemisphere, but after Arcturus. So, Arcturus is actually brighter than Vega.
Oh, really?
Yeah.
I mean, Vega is the fifth brightest star, so
Yep.
what would Arcturus be?
It's
Do you
like
know?
in yeah,
I mean,
but it
it's a
does
red
look brighter
giant star.
in the image as well. If
Yeah.
you know.
Yeah, it looks really bright.
It's the classified as the brightest K type red giant. So K03. It's classification spectral type. And it's actually 1.5 times bigger than our sun. So yeah.
Oh wow, that's big.
Yeah. It's actually expected to become a white dwarf in the
Mm-hmm.
future
Oh,
because it's fusing
yeah,
helium
it
into
is.
carbon.
Mm-hmm.
Yeah.
Yeah, so it is in that developmental phase where it is done with the burning of hydrogen to helium, and now it's just burning from helium to carbon. So it must be an old star.
Yeah. But its age is roughly, they are not 100% sure yet, and they think it's 7.1 billion years old, although our sun is like 4.5 billion years old.
Mm.
But still, the range is, we still expect it to be like 6 to 8.5 billion years. So, yeah.
And again, like because it is, as you said, it is burning helium to carbon now, which like that explains why it is so bright.
Yeah.
And it obviously produces a lot of heat as well.
Actually, with our Teletube being about Jupiter, this star is 12 times larger than the Jupiter. So there's one comparison there.
As we learned in the rest of Teletube, Jupiter is really big. So imagine how big that this is, right?
Yeah.
Yeah. So, guys, we had a great live viewing session, but I believe we should get back to the show and discuss about Jupiter now. So, I'm gonna take back the screen share. Alright, so thank you to our team for some great live imaging tonight. Now, without any further delay, I will now hand it over to Arfa to talk more about the formation and history of Jupiter.
Thank you, Maheen. So starting off for Jupiter, how long ago and the various theories about it. Jupiter, the biggest planet of our solar system, named after the king of the ancient Roman god. Jupiter is believed to be formed about 4.5 billion years ago. However, there have been various theories of how this great giant was formed. In past, it was believed that Jupiter was formed where it orbits now. Since it was hypothesized to be just formed with hydrogen and helium, but after the Galileo spacecraft discoveries in 1990s, of various other elements like carbon, nitrogen, sulfur, krypton, and xenon, which are much heavier elements, scientists passed this theory that Jupiter was formed somewhere in the region beyond the orbit of Neptune. You all must be wondering, how does the discovery of these elements lead to this theory? Well, all of the heavier elements can only be formed in colder temperatures and then mixed with materials in warmer conditions, which may lead to another theory. It might be possible Jupiter was formed where it orbits right now, but it might have trapped the heavier metals inside ice crystals that populated Jupiter's neighborhood. As the planet formed, it gobbled up these crystals. Formation. Jupiter started as a gas giant of more mass than 2.5 times than all other planets in the solar system combined, except for the sun. And it is slightly less than 1,000 than the mass of the sun. Jupiter has the same ingredient as the star, but it did not grow massive enough to ignite. If we talk about the most common theory, so we can predict Jupiter began to form at a distance of roughly 3.5 AU. As the young planet aggregated mass, interaction with the gas disk orbiting the sun and the orbital resonances with Saturn caused it to migrate inwards. It all started around 4.5 billion years ago. At 4.0 billion years ago, Jupiter settled into its current position in the outer solar system, where it is the fifth planet of our solar system. Given the planet's large proportion of hydrogen and its huge mass, it has been traditional to assume that Jupiter formed by condensation from the primordial solar nebula. This hypothesis implies that the elements should all be present in Jupiter in the same proportions that they occur in the Sun. However, the most recent evidence indicates that the elemental proportions in Jupiter differ from the solar values. Who and how was Jupiter discovered? Observation of Jupiter dates back to at least the Babylonian astronomers of the 7th or 8th century BC. Jupiter is known from ancient times, but Galileo was the first one to make observation about Jupiter through his small telescopes in the year 1610. The unique spots and colorful bands of this planet were discovered by Giovanni Cassini in 1660 using a new type of telescope. He also discovered that the planet is oblate. He not only did that, but also he was able to calculate the planet's rotational speed. He continued to make discoveries, like in 1690, Cassini noticed that the atmosphere undergoes differential rotation. Guys, we are talking about 1690s here. Another discovery by Cassini is that he was able to discover the famous Great Red Spot, but it's a dispute between him and Robert Hooke. In 1932, Robert Wilt identified absorption bands of ammonia and methane in the spectra of Jupiter. It was later on discovered in more depth, which my colleague Matt will discover in next few slides. Galileo not only discovered these planets, but also its 4 moons, which I will talk about next. Jupiter's moon. Jupiter has 79 moons in total, 53 named, and 26 still waiting for official names. Most famous ones are the 4 largest moons of Jupiter, called Galilean satellites. Io. Io is about the same age as Jupiter, 4.5 billion years ago. It is the 5th moon from Jupiter. By the scientific research and computer models, it is predicted that Io was formed in a region around Jupiter where water was plentiful. Io's heat combined with the possibility that there was water, but due to Jupiter's radiation, the water would have been removed from the surface, or else there was possibility of life on Io. Anyways, it is one of the most volcanically active body in the solar system. This colorful moon gets its color because of presence of sulfur in its surface. Next one is Europa. Europa, also known as Jupiter 2, is the smallest of the 4 Galilean moons orbiting Jupiter, and the 6th closest to the planet of all 79 known moons of Jupiter. Ganymede. It is the largest moon in the solar system and is even larger than the planet Mercury. It is also the only moon to have its own internally generated magnetic field. It is hypothesized that it took this moon 10,000 years to have formed and was formed by the accretion in Jupiter's subnebula, where the gas and dust surrounded the planet. Last but not the least is Callisto. Callisto is Jupiter's 2nd largest moon and the 3rd largest moon in our solar system. Callisto is about 4.5 billion years old, same age as Jupiter. It is the most heavily cratered object in the solar system, according to NASA. Now, Shannon will tell us more about the planet Jupiter.
Thank you, Arfa. Jupiter is the biggest planet in our solar system. Jupiter is so large that, as Arfa said, that if you combined all the planets in the solar system, Jupiter would be twice as massive. Jupiter is about 11 times the size of Earth, 317 times its mass. Jupiter has a radius of 69,911 kilometers, which means that if Earth were the size of a nickel, Jupiter would be as big as a basketball. Jupiter is on average 778 million kilometers away from the Sun. In other words, Jupiter is 5.2 astronomical units away from the Sun. Astronomical units, also known as AU, is the distance from the Sun to the Earth. With this distance, it takes sunlight from the Sun 43 minutes to travel to Jupiter. Surprisingly, even though Jupiter is the largest planet, it has the shortest day in the solar system. For instance, one day on Jupiter is only about 10 hours. This means it takes only 10 hours for Jupiter to rotate or spin around once. Jupiter's complete orbit around the Sun, which is a year in Jovian time, is about 12 Earth years. That is 4,333 Earth days. Wow! With respect to Jupiter's orbital path around the Sun, the equator is tilted by 3 degrees. The smaller tilt means that Jupiter spins nearly upright and does not have very extreme seasons as many of the other planets may have. So you may know Jupiter is a gas giant. And if any of you guys have ever seen an image of Jupiter, you know how colorful and beautiful it is. Jupiter's stripes and swirls are cold, windy clouds which are made of ammonia and water. These clouds are floating in an atmosphere of hydrogen and helium, which is very similar to the sun. Jupiter has three different cloud layers that in a total span about 71 kilometers. The top layer is a cloud made mostly of ammonia ice. The middle layer is most likely made of ammonium hydrosulfide crystals. The innermost layer is most likely made up of water, ice, and vapor. Jupiter has very thick bands of vivid color that are not only just eye catching, but very interesting as to how they form. These bands may be plumes of sulfur and phosphorus gases rising from the planet's interior, which is much warmer. Jupiter rotates very fast. As I said, it spins once fully every 10 hours. The fast rotation creates strong jet streams, which separates the clouds into dark belts and brighter zones along the planet in long stretches. Jupiter does not have a solid surface to slow down its storms, which means that they can persist on for many years. Jupiter is constantly swept over by dozens of prevailing winds. Some of the winds are so strong they can reach up to 539 kilometers per hour at the equator. Now, you may know about Jupiter's Great Red Spot, which is a giant storm that is bigger than Earth, precisely twice the size of Earth, and it's been raging on for hundreds of years. The Great Red Spot is a swirling oval of clouds that has been observed for over 300 years. On recent news, three small ovals have merged to form the Little Red Spot, which is about half the size of the Great Red Spot. However, with a lot of observation and research continuing on Jupiter, scientists are still unsure if the ovals and bands are shallow or deep. It may come as a surprise to some, but Jupiter has rings. Jupiter's rings are very faint, and unlike Saturn's rings, they're not made of ice. Instead, they're made of dust. Jupiter's rings were first discovered in 1979 by NASA's Voyager 1 spacecraft. It was very surprising to see Jupiter's rings as they can be very difficult to see except when backlit by the sun. Jupiter's rings are composed, as mentioned earlier, of dust, which is made of small dark particles. Thanks to data collected on Galileo's spacecraft, it is assumed that Jupiter's ring system was formed due to interplanetary meteorites smashing into Jupiter's small and innermost moons. As mentioned earlier, Jupiter is a gas giant, which means that it does not really have a surface. It's mostly gases and liquids swirling. This means that yes, a spacecraft would have nowhere to land on Jupiter, but surprisingly, it would not be able to fly through the atmosphere either. Jupiter has such extreme pressures and temperatures deep inside the atmosphere that the spacecraft would be crushed, melted, and vaporized just trying to get into the planet. In the deep atmosphere, the pressure and the temperature increases, which causes hydrogen gas to compress into a liquid. This is the reason why Jupiter has the largest ocean in the solar system, an ocean made up of liquid hydrogen. Scientists have claimed that halfway to Jupiter's center, the pressure is so great that electrons are squeezed off the hydrogen atoms, which in turn makes the liquid electrically conducting like that of metal. Therefore, with Jupiter's fast rotation, electric currents driving in this region generate the planet's powerful magnetic field. It is assumed that deeper down, Jupiter has a central core of solid material, or it could be thick and hot, dense liquid. The core could be up to 90,032 degrees Fahrenheit, also known as 50,000 degrees Celsius, made mostly of iron and silicate minerals. As I mentioned, Jupiter has a very powerful magnetic field. It is so powerful that it influences a region of space known as the Jovian magnetosphere. Towards the Sun, the Jovian magnetosphere balloons from 1 to 3 million kilometers from Jupiter. This is 7 to 21 times the diameter of Jupiter itself. Then the Jovian magnetosphere tapers into a tadpole-like shaped tail, extending more than 1 billion kilometers behind Jupiter. This is as far as Saturn's orbit. Now we know that Jupiter has an enormous magnetic field, but It is 16 to 54 times more powerful than that of Earth's. The magnetic field rotates constantly with the planet, and it sweeps up particles that have any electric charge. Closer to the actual planet Jupiter, it has an intense radiation that can bombard the closest moons. And this is the reason why spacecraft cannot travel very close to the planet. The intense radiation is created by the magnetic field trapping swarms of charged particles and accelerating them to very high energies. Now, in summary, as I explained, Jupiter has a very beautiful and large magnetic field, but can also be very stunning. It creates one of the most spectacular auroras at the planet's poles. Now, on to you, Matt.
Thank you, Shannon, for letting us know a bit more about this amazing and beautiful planet, which, if I'm being completely honest, it is my favorite one. Reason why I was excited to do some research about the several missions that had a chance to study Jupiter. The most important one would be the Juno mission, whose sole purpose was to study this gas giant. We've already made a Teletube about this mission, actually, so make sure to check that out if you're interested in learning more about how this mission worked and all the behind the scenes of its discoveries. And let's start with a few things we discovered. First of all, what Juno helped us see for the first time was the north and south poles of the Jovian system, of the Jovian planet, I'm sorry, giving us some stunning images of the circumpolar cyclones and storms that happen to be extremely symmetric, forming an octagon in the North Pole and a pentagon in the South Pole, as well as the presence of shallow lightning in the storms produced on the North Pole of Jupiter. And another interesting discovery was the corrected amount of water abundance in the planet's atmosphere. Water makes up about 0.25% of the molecules in Jupiter's atmosphere, and we know that because of Juno. And especially near the equator, water is more abundant and it is greater than what the Galileo probe measured to be in 1995. And moreover, Juno has found some interesting data related to the gravitational field of the planet and also the magnetic field, which shows that variations in Jupiter's inner structure will have some effects on its gravitational and magnetic field. Um, and it also shows some variations specifically to the atmospheric winds. And other interesting discoveries are the detection of high energy ions, electric potentials associated with Jupiter's aurora, as well as the movement of magnetospheric hot plasma. The mission is expected to end actually this July, but don't worry because it wasn't the only one that has studied this planet. Voyager 1 made its closest approach to Jupiter on March 5th, 1979. It came within 349,000 kilometers from the center of Jupiter, so it was actually pretty close. And this close distance allowed for high quality images, of which many were taken. Also, observations of the moons, rings, and magnetic field and radiation belt of the Jovian system were undertaken. Our understanding of Jupiter, its moons, and other aspects were greatly advanced by the Voyager missions. Jupiter's rings were discovered, as I mentioned before, and the first pictures of its atmosphere were taken by the Voyager craft. The Great Red Spot was observed and identified as a giant storm that is moving counterclockwise. And then Voyager 2 began transmitting images of Jupiter on April 24th of 1979 for time-lapse movies of atmospheric circulation. And unlike Voyager 1, Voyager 2 made close passes to the Jovian moons on its way into the system, with scientists especially interested in more information from Europa and Io. Voyager's two closest approach to Jupiter occurred on July 9th, 1979, when it came within 570,000 kilometers of the planet's cloud tops. Voyager 2 returned images of Jupiter as well as its moons, Amalthea, Io, Callisto, and Ganymede, and Europa as well. During a 10-hour volcano watch, it confirmed that Voyager's 1 observations of active volcanism on the moon Io and revealed how the moon's surface had changed in the 4th month since the previous visit. And together, the Voyagers observed the eruption of 9 volcanoes on Io, and there is evidence that other eruptions occurred between the two flybys. Jupiter's moon Europa displayed a large number of intersecting linear features in the low resolution photos from Voyager 1. Two new small satellites, Adrastea Metis, were found orbiting just outside the ring, and a third new satellite, Thebe, was discovered between the orbits of Amalthea and Io. And there were also other missions aside from Juno or Voyager that were able to help us study Jupiter in depth. Another important mission, first of many, was the Pioneer 10 mission. It was the first spacecraft to fly beyond Mars, and also the first to fly through the asteroid belt, as well as the first to fly past Jupiter. Pioneer's 10 closest approach to Jupiter was on December 4th, 1973, when the spacecraft took many of the first colored images with great detail of the Jovian planet, as well as some of its moons, and obtained photos of Callisto, Ganymede, and Europa. Pioneer 10 also had a special mission on Jupiter, reason why 78 minutes after the closest approach, it passed behind Jupiter's limb for a radio occultation experiment, as well as the study of the planet's atmosphere using an infrared radiometer. In total, Pioneer 10 took 500 pictures of the planet's atmosphere, as well as important landmarks such as the Great Spot in high resolution. Finally, due to Jupiter's intense radiation, the Pioneer 10 spacecraft couldn't fulfill all of its objectives in the Jovian planet, and since it triggered some false commands, and the mission decided to end the encounter with Jupiter and establish a trajectory to Saturn. And now, these were some of the most important missions that have made us learn a little bit more about this fascinating yet mysterious gas giant. There are a lot of things we still need to discover about Jupiter, reason why there are several missions that plan to study it in the near future. NASA's contribution with the European Space Agency, JUICE, or Jupiter's Icy Moon Explorer, plans to launch in June 2022, which is the one on the left, the image you're looking at on the left, with the sole purpose of studying Jupiter's Galilean moons, Callisto, Europa, and Ganymede, focusing on the possibility that they all may hold bodies of water beneath their surfaces, making them, of course, an ideal candidate for a habitable environment. And another one of the main missions, the one you're looking on the right, that will be heading to Jupiter is the Europa Clipper, which is the mission designed to go into an orbit around the gas giant in order to do some close flybys to its most interesting moon, Europa. The purpose of this mission is to study the ice shell on Europa's surface and to study the composition and chemistry of the ocean underneath, as well as the potential habitability, and understand that the formation of the surface features and other high science interest sites. And for this mission, we'll have to wait till 2023 to see what happens. But till then, I invite you to do more research and investigation on this majestic planet. Such a masterpiece that belongs in the best museums. Next to art pieces from Van Gogh or Monet, Jupiter will still be the one to take your breath away. And well, everyone, you have been listening to the Alan I. Carswell Observatory's weekly Teletube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Maheen, Arfa, Shannon, and myself, Matt. Make sure to leave any comments or questions in the comment sections of the video and talk to us in the chat right now. We'll be around for the next 20 minutes to answer your questions. All of our programs are free, but if you would like to make a donation, you can see our website at observatory.info.yorku.ca. And you can always connect with us on Twitter with the handle at York Observatory, and check our website for show notes, content, updates, and contact info, as I mentioned before, at observatory.info.yorku.ca. Thanks for tuning in. Clear skies and have a great night.